We are a research institution. I am the CTO of a research institution, as you can tell from the woman who's very prepared right in front of you, right? Big boss lady, right? And research means collaboration. We work with these wonderful organizations, FFTW, NLNet, MetaMask, Gilead, Agoric. Maybe you want to be one of them. Maybe we should talk to each other. But you know, we call ourselves the Spritely Networked Communities Institute, right? We've got network communities in there. So we went, well, what are these people? What do they know about any of this stuff, right? Well, I know a little bit. Who here has ever heard of ActivityPub? Raise your hand. Okay, that's a large portion of the audience. Who here has heard of Mastodon? Raise your hand. Okay, that's almost everybody. Okay, Mastodon uses ActivityPub. Hi, I'm co-author of the ActivityPub spec, most popular decentralized network spec in the world. So we have a certain amount of experience there. But even further back than that, I don't know how I inserted that header there. You know, we've oh, I know exactly what I did, and I made a typo right before I released this. There's other things that are actually interesting, as in terms of like here is an interesting document talking about goals for what cyberspace should be, written in 1995. That things should be scalable, open, decentralized, traversable, commercial, social, and secure and portable, written all the way back in 1995. What's kind of interesting is that this was built. Right? So in the mid-90s, here was a decentralized virtual world. People could trade, you know, it was fully peer-to-peer, secure, end-to-end encrypted. You could safely run code you didn't trust, and you could exchange money with each other and goods and stuff like that. And this all worked back in 1995. So my co-founder, Randy Farmer, worked on this all the way back in the day, and actually ran the world's first online social community, which was Lucasfilm's Habitat in 1985. So we've been doing this stuff for a while, and so presumably what you're expecting is something like this. And this is indeed the high-level goals of the type of stuff that the Spritely Institute is doing, right? Building applications for users to talk to each other on the internet. Which is generally what you would think that a Network Communities Institute would do. But I'm not here to talk about that part. I'm here to talk about lower on the stack. And the reason for that is that it is too hard to build these things right now. These things have been built before, but the general architecture that we have, that we usually throw in front of developers and say, hey, go make this cool world, it's like peer-to-peer, you're like, I have to think really hard about this, I have to think about a lot of details. I'm going to show you a different perspective, the way that we're showing about doing things, where this is secure, peer-to-peer, and encrypted, all those types of things. Those are the things you get by default, and the environment makes it easy for you. And the ways of doing this have been well understood. We're pulling them forward into the present day in reality. But today, I think the general perspective is that, well, secure distributed programming is hard, right? You have to think a lot about the perimeter to get these two different processes over the network to talk to each other. You know, how do you deal with all the security problems and stuff? Well, we have something called Goblins. This is our base level programming environment. It's distributed, cooperative, transactional programming. That's a lot of interesting words. Let's unpack that a little bit. So by that, I mean, when you are programming in Goblins, you are actually, the program that you are write, by default, is able to communicate with other programs across the network securely. And part of the reason for that is that we're taking an object capability security paradigm. So if you saw Brooklyn's talk yesterday, you can consider me in the same category as Brooke, as in terms of we are advocating object capability security. I'm like a much less well put together Brooke today. But the core idea when you apply this to the language perspective is that if you don't have it, you can't use it. So in other words, security can be perceived as simple as what developers do every day, which is passing around arguments to functions, right? We're used to doing that. Now, from a high level, our network looks something like this. You know, we got all these things pointing at each other. We have machine 1 talking to machine 2. There are these different objects that have references to each other, and they're communicating with each other. But what's interesting here is that nothing in the network can communicate with the stuff it doesn't have access to. But from a programmer's perspective, as you'll see, this just looks like ordinary code that you end up writing. By default, the security perspective of like who's allowed to access what is the same type of code flow that you normally do every day in programming. I'm not going to go into the details of how all this stuff works and how it ends up getting into the transactionality, because this is an overview talk and we have a lot to cover. But there is an interesting model of computation you may want to look at if you find this stuff curious. It's called the VAT model of computation. Instead, I'm going to show you off the space shooter. It's running in the terminal. Why on earth would I be showing this, right? You know, okay, well, it's cool. See some space things playing around with the space shooter, and this is the part 1 use of this is to show you that, of course, you can do real-time things with this, despite it being distributed. No reason you can't do it for real-time stuff. But we'll get to why this is more interesting in just a second. which is that error recovery is really difficult. So right now, when if you're running code and something breaks, right, getting back to the state and cleanup is one of the hardest things that programmers have to deal with. Here is an example of a bank written in Spritely Goblins. It's about 30 lines of code, and it preserves, even if there's an error in this code where it breaks in the middle of it, say you're decrementing something from one account and you're incrementing in another, it will automatically move back corrupted state. This happens without the developer having to think about because of the kind of quasi-functional approach we're taking. But remember that space shooter I showed you? Here's another interesting thing. Transactionality, of course, is the ability to move back after something's happened. What's unlimited transactionality? Well, let's find out, right? So, it's time travel, right? So you're playing this game, you're beep boop, you're moving around your little ship. This is all ASCII art, by the way. Runs on a developer's terminal, and so like the developer, so the player, they hit this asterisk, and they can move back and forward in time. And that's because the interesting thing about this is that this was written as like my personal test project for Goblins early on. This entire game was written without thinking about anything about time travel being a component that we could expose to users. And I just said, right, we have time travel. And I just, in an hour, put a user interface on top of it that let you be able to play with it. Right? Not a single line of code had to be changed or even designed for to permit this. This is the default that you get with the programming paradigm we're talking about. Now, if you ever, who here would agree with me with the assessment that debugging asynchronous networks is extremely hard, right? Hopefully everybody. It's very hard, right? Well, we're going to make it a lot easier for you. And we have this lovely character right here. Goblins also provides the ability to not only have a distributed debugger, but in fact a time-traveling distributed debugger. The world of time unfolds before you. And how? What Goblins is able to do is that when errors occur, it's able to actually lay them out within a graph that's sensible to the user. It's able to kind of lay them out similar to how users are used to working with stack traces. We're able to build causality trees. And I'll show you one of those in a second. But what you're also able to do is you're saying, gosh, why did this thing happen? And you're able to, what's happening is that the user is moving, I cut off part of this, but the user's moving up and down. This is from one of our blog posts. The user's moving up and down effectively the, what's more or less something like a stack, but across multiple event loops on the network. And they're saying, what happened on this network? Why did this thing end up breaking? Why did this, I'm playing this game, this character, is supposed to be, they're supposed to be dead at this point. Why is this monster not dead? Right? And so they're walking back and forth through the history. Well, they're able to move to one of those frames and just say, actually, show me what the object would do at this particular moment. And they're able to do it in a clean room environment where it won't affect any of the rest of the code. They can do that instantaneously, just walking through the code, just walking back and forth through the history. Now that, I imagine, would make a lot of people's lives a lot easier in terms of dealing with distributed programming. But here's also interesting. Here's a Lamport diagram. Cool thing about our interface, you just type, I believe it's vat graph, like comma vat graph, and right in the developer's terminal, where they're working, where they're building their program, it will print out a Lamport causality graph like this that explains, well, this happened because this thing was talking to this thing, and then this thing was doing this to this thing and this thing. It's able to reconstruct that from a bunch of asynchronous messages flowing over the network. And this type of stuff just happens automatically with the stuff that you're working with. Now, network protocols, as we all know, very difficult. You have to think a lot about them. I've certainly thought a lot about them, right? I've been on standards committees for them. Well, what if we could eliminate thinking about network protocols from our lives? Screw working on network protocols. It's the worst, right? I say to a room of people who largely probably work on network protocols. Let's destroy them, right? And we will destroy them with the power of generality, right? Generality is how we stop thinking about particular things by finding the general way of being able to accomplish problems, right? So, what if we could do some pretty cool things like this? Like, so here's something that we call OCapN. It's the Object Capability Network. I know I mentioned Goblins is able to do some cool shit. They're able to get these things to be able to just talk to each other pretty much automatically over the network. Well, we are working on making this protocol available for everyone. Now, you're not going to get the time travel for free. You're not going to get all these other cool things I showed you for free, right? But if you want to be able to securely have your programs talk to each other, we are generalizing the project, the way that these things work, and are working in a pre-standardization process for what we are calling OCapN, the Object Capability Network. There's some pretty cool shit about this. So if you don't like the word shit, I'm sorry, I've said it like 40 times in my talk. So for one thing, there's distributed garbage collection. What? Right? So you can have multiple, not only are you having these multiple programs, and it looks the same to the user as if they are programming against an object that is local, as if they are programming against an object over the network. Looks the same. But not only that, the different processes are able to securely cooperate to say, hey, I don't need this object reference anymore. And it just happens, just gets cleaned up, right? You don't have to think about it, right? That's cool. There's also this whole thing about flexible net layers. So our base implementation is that we did as our first example is on top of Tor Onion services. We're now looking at doing a net layer on top of libpdp. But the cool thing is, this really means that our abstract protocol for how the objects talk to each other in the system is actually abstracted in such a way that you can layer that on top of different substrates of network communication. So all you have to do is provide the particular interface. So us adding libpdp on top of our capTP support, which is the capability communication stuff, that's something we've actually designed to be able to make it so that you can swap out those components. You use Tor Onion services, you could use libpdp, you could put some encrypted micro SD cards in the backpacks of carrier pigeons and fly them around from place to place. Doesn't matter. Same abstract idea, it all works, right? Promise pipelining. You may have heard Brooks talk about this. Here's my way of talking about it, right? What if you wanted to send messages to objects that don't exist yet, right? You've got a car factory over here, and you say, hey, you're programming, you say, hey, I want you to make that car, but also I want to drive that car immediately. You can just send both of those network messages at the same time, and it's integrated with local programming language so that you have the convenience of not having to think about setting up a callback for this. It's all integrated very carefully with network programming and flows. Now, you don't have to think about any of this. That sounds like some cool features, but you're like, wow, it must be really hard to hook all this stuff up. Here is a chat program, and encrypted, peer-to-peer. You see multiple programming languages implementing this chain chat system, and multiple people talking. None of them can forge having messages from each other. This is across 2 different programming languages. It's only 150 lines of code for the code that covers the user and for the code that covers the chat room. That's it. And this was fully written locally on a developer's machine without even testing or thinking about how it would work over the network. You hook it up to OCapN and it automatically worked. That's a different way of thinking about programming and doing network programming. So, explaining these ideas, it's hard, right? It takes a lot of effort to be able to get people to be able to be like, oh, okay, I can use and I can pick this up and do this. Well, we are working on writing multiple papers. Here's a paper about our abstract object system that we are building, right? And we want you to take this and we want you to steal these ideas, right? We are a research institution because we are trying to figure out how to take these things and provide them to the rest of the world so that it's not just us nerds in our world of Lisp and stuff like that that are doing this type of shit. It's everybody who's able to take it to every programming language. We're talking about that on the social levels too. Today is a very programming-oriented talk. There are times where in building a social system, the low-level primitives and the high-level ways in which things are represented to the users match, and an identity system is one of them. We, doing write-ups about those types of things too. And oh, this is weird, because this is like one of the most popular posts on our website. It's called the Scheme Primer. This seems like an incredible distraction, right? Oh no, it's those Lisp people talking about putting their parentheses everywhere. This is weirdly the most popular thing we put on our website. It was kind of like a side effect of trying to do the other things we were doing. And that actually brings me to an interesting thing. Building these abstractions is hard, right? Oh, it's really hard to figure out how to make all this stuff work. Why would you, how do you even figure out how to do some of the weird shit I've showed you how to do today? Well, so this is why we end up in the world where you see all those parentheses everywhere. We are borrowing on a tradition of of the Lisp world. So I don't know how many of you have spent much time reading through all the old MIT AI Lab archives. If you haven't, do it. It's great. It's a wonderful way to increase all your experience and time, and definitely spend hours in ways that people would prefer to be socializing if you're like me. But instead, you can gain all sorts of skills because all these things were encoded in knowledge and time. The reason that we're doing stuff on top of Lisp is because doing the research to figure out how to be able to make these things available for everyone requires having an environment in which the substrate of being able to play with the ideas is malleable and is like clay. There's a reason why so much of the history and programming patterns that have been shared with the world ended up coming out of only a couple of decades that were happening in early programming language research and largely out of this development community. So aside from being a smug wisp person, nobody's going to be able to run that thing in the browser, right? Well, we are doing an interesting project now in collaboration with Consensus. We are compiling to WebAssembly our particular scheme and Lisp environment. But you're like, oh, so you're trying to make all our developers use your scheme crap? Well, we're calling this project Hoot. This is get your scheme stuff compiling to the browser. But actually, there's a different reason for doing this. Right now, the perspective I think people have is in terms of how do you get stuff onto the web is one of two things. It's either you use JavaScript. Everybody's like, okay, I guess we'll use JavaScript. Or you're like, oh, here's a language I really like. And and you're like, well, maybe we could compile it to WebAssembly, right? So WebAssembly, really great. But for most people that I think right now, their perspective is like WebAssembly, it's a thing that C and Rust programmers get to have, right? You compile to that thing, and it's like this low-level world, right? And if you want to do something like Python, or maybe Scheme, or maybe like Lua or anything else like that, what you have to do is compile your whole underlying language, right? Your whole, well, we are working with other folks, like some of in advancing some of the work is in terms of how to compile to WebAssembly for languages that are not that are in the broader spectrum. Because what we really want is the web to be for everyone, regardless of your particular choice of language, that everybody is able to be represented on the web. And in general, this actually kind of reflects our general perspective, is that everything the Spritely Institute is doing, our real goal is to be able to try to lift the general state of computation for everyone, right? I said we are a research institution. Take our ideas, steal them, and move them to elsewhere, right? And that is because that is explicitly what we are trying to do. We are a research institution. Please work with us, right? You're not a good research institution unless you share your research, which we are doing. And also people find your research and they say, gosh, I would like to implement this research and I would like to bring it into other parts of the world, right? This is what we're trying to do. We're trying to change the shape of the internet by building cool stuff that sometimes people didn't even think is possible and get it out there so that everybody can take it, and eventually it's just kind of like oh yeah, that's just how everybody does it, right? So, this was an incredibly rambly talk. I'm Lemmer-Webber. I hope you enjoyed the end of your conference where everybody's usually very tired and everybody's like ready to go to sleep. Instead, you had Christine come up on the stage and just like rant at you for like half an hour. Do you have any questions? I promised this would be an energetic talk. I hope I delivered. I could go try to drink some more caffeine if I am not sufficiently energetic at this point. Just let me know. Does anybody have any questions? I see somebody over here who has a question. Well, there's a microphone coming to you. I will drink some water while you're recording this microphone. Or speaking.
Yep, I'll take my time. So you showed a bank transaction, you showed a console shooter, you showed a chat program. In your ideas and dreams or in other, what are other applications people have talked about maybe related where there's, say, significant data, right? So we've got some giant store of data, we want to compute on that. What are directions that we should look at taking Goblins?
Yeah, so you know what? A really funny thing, you probably saw me like kind of just completely like lose it in the middle of my talk where there was like this weird text that was on there. And that's because I'm exporting from a plain text system where I'm writing my talk. And I, finishing my slides at last minute, coming up here. And a whole bunch of slides actually dropped out of my talk. So I'm going to walk you through them instead. The answer is anything that you are building that could be talking over the network, this is a suitable substrate for being able to build those things, or at least taking the ideas that we are doing and building them on top of whatever language you actually like, right? So let me give you a bit of an idea as in terms of how this is very general, right? So if you want to build a distributed programming environment, if you want to build a distributed, like maybe you want to have somebody else, do some computation over some sort of series of, you've got multiple people who want to do computation as in terms of they want to get bioinformatics, very popular at this conference, right? There's no reason you can't end up breaking things off into multiple nodes, just sending messages to other parts of the network and saying, hey, do this computation, and pull it all back in, right? What I want to give you an idea of, though, is that this is general, and in fact, it's more general than we are used to thinking about network programming being. And so the first week on the job, our lovely programmer, Dave Thompson, I said, okay, you've had a couple of days to learn about this Goblin stuff. Build me an example application. You've only been a couple days in. And he's like, oh, I don't know, I like gardening. I'm like, cool, show me a community garden. Right? So he built this little community garden, right? One day he did this, about an afternoon. Got some plants in it. Now here's the interesting thing. The roles is in terms of collaboration that are in here. You're going to see them all. There's no access control list. There's nothing. It's only the code you're going to see. Here's a garden. It's a shared growing space. There's a gardener, who's somebody who can modify your garden. And then there's a botanist who can improve plants. The last one is just for visualization and debugging. Those are all you're going to see. So the botanist, this is all the code there is. The botanist can say which plants are and aren't allowed. The garden is just this much code. The gardener is this much code. That's it. That's the whole thing of this. Now, the rest of this is just hooking it up to our network stuff right here. That's it. And also saying we're going to approve sunflowers, right? So I said to Dave, oh, okay, make it so that, it just prints out text. But since Dave's Dave and likes to work on game engines, he made it pretty. But here's an actual live example. Dave did this in one afternoon. And the next morning, or actually before he signed off of work, he said, oh, I already have it. And remember, no experience doing any of this type of stuff before. In only 3 days on the job. What you'll see here is that this is an interaction of the both of us. He set up, he wrote all this code and said, okay, connect, and I start planting stuff and digging up various plants. And here's what it looks like, right? You got I managed to contribute this. Now, what's interesting about this? Why did I show this thing, right? This garden, what does it have to do with anything, right? This seems incredibly silly almost, right? Like, okay, garden. Seems weird and it seems abstract, right? Here's one of the things, and I say this as a person who has worked on social network protocols, probably definitely the most popular social network protocol that exists on the web right now, today, right? We are used to social things being considered very narrow domains. What if every code could be a code that you could write, could be networked and could be social and could be collaborative by default? What's interesting about this is that none of this code was written up to the moment that he said, okay, try connecting. Not a single part of this code was written mentioning or having to do with anything on the network. Same thing with the chat program I wrote. It's just written as code that the user was playing with locally. And then the moment they said, hook it up to the network, it did it. So imagine that every piece of software that you are writing has the capacity at any component of it to be able to share that particular component and say, I want other users on the network to be able to collaborate on this particular part. Everything, right? So the question of what could you do with it? The question is, what can't you do with it? And the answer should be nothing, right? Because the whole thing is designed to be like this. Every part of your code could be networked and social. That is the thing that I'm trying to drive home here. And that's, I think, a change in perspective.
And when you connected as a certain role, which ran a certain set of logic on your machine? Great
question, right? So what happened is, I don't think we actually have a screenshot of it, but we do in we do in an older one. So it's the same actually as with the. So you've probably gotten a Google Docs link or something like that before, right? And you've got this particular URL, right? If somebody handed that URL and you didn't know it was going to be there, you could connect to it and then load the page, right? And you're able to interact with it. Right? So same thing. It's a capability to a particular object. So what he actually handed me is he just pasted into our chat room, here is the capability for the thing that you're going to interact with. And I just opened up my terminal and I just started sending messages to that object that he gave me. That's all he had to do. And what it was is just a URI with a bunch of gobbledygook attached to it. That's what it looks like in those. Now, there are multiple ways to do capabilities. You don't just, and so that's what happens when a user is sharing a link to the chat room. Now, multiple of these users do have to have this chat program locally in order to be able to have the same kind of behavior on here to some extent. There's a separate thing I have not talked about here, which is secure evaluation of code you do not trust, which we also know how to do. And if you're familiar with the JavaScript world, you've probably seen similar ideas with the frozen realms and the SES and stuff like that they've been doing. I guess it's called Endo now. Even if I did not have a particular program that wanted to represent this way in particular, if somebody sent me a reference to that particular object, and here I was talking about a URI with some unknown information with like a bunch of random stuff attached to it, right? You can also do it similar to what you've probably heard Brooklyn talking about OCapN, right? Which is in the tradition of what's called certificate capabilities, right? So you can also use certificate capabilities. But what you're being given access to is particular objects. And once you have that object, you're able to do whatever is appropriate, whatever the possible behaviors are with that object. Does that answer your question to any degree?
Yes.
Okay, excellent. Does anybody else have a question?
Oh man, I have a lot of questions. But I guess just on the last thing that you said, like who does the verification of the appropriate action, and like how do they verify that it's the right action on the given object?
Good question. The answer is the person who programmed the object and also instantiated the object makes the decisions about what type of things are possible with it. So so I'm gonna get very nerdy here for a moment. Let's talk about the actor model, right? So the formal rules of the actor model. 3 things. An actor can do 3 things in response to a message. It can create other actors and then have a reference to it. It can send messages to actors it already has a reference to. And it can change its behavior in response to a message. And actually, that last one, doing that functionally, is actually the way that we actually get all the time travel stuff. That's the fun fact there. And all the transactionality and everything. The interesting thing is that, so the interesting thing is that the object itself that's being programmed. So for example, if I set up an object, like with the gardening demo, the garden was specifically set up to say, okay, here is the code of what the botanist does, right? The botanist has certain behavior, right? It can change its behavior in response to messages that come in, but the person who programmed it, and then also the person who instantiated it and gave it whatever its initial state is, are basically responsible for what can be done if you have a reference to that. But what's interesting is, it doesn't have to end there. So for example, what if you wanted to hold somebody accountable for the way they use this object, right? Sounds like there's not enough accountability here. It sounds like you can't revoke things. So right, what if instead of handing you access to, what if I wanted to permit you to become a botanist, right? But I wanted to know, so there's been some sneaky botanist who's been going around, and they've been approving Japanese knotweed, right? Like, it grows like crazy around here. I don't know if you ever had Japanese knotweed. Delicious, by the way. You can make a compote out of it, like rhubarb. But anyway, definitely don't want to approve Japanese knotweed. Somebody's been approving Japanese knotweed. How do we find out what to do, right? So what we could do, here's a botanist object. Well, we have a reference to it, right? Here's the address that points at it. What if instead of handing them the reference to that, we put a proxy object right in between the 2 of them? And the proxy object, they will never get access to this direct object. They'll get access to the proxy. The first thing we could do is we could put a little flag in it that says, oh, hey, you know what? If it turns out I don't trust this user, I'm going to set this flag, and it just doesn't forward messages. So normally it just forwards messages to the other object, and it just acts, like it's kind of a dummy object that just forwards them. So, but also I can revoke access by this other object that I say, okay, I don't want that anymore, flips a Boolean that says, okay, I'm refusing to forward messages. That's pretty easy to understand. Well, what you could also do, what actually happens in this demo, is Dave then says, okay, well, what if I want to hold Christine accountable, right? And so he adds this audit logging. And this is all the code that's needed to add the audit logging. Is what it does is it's an intermediate set of objects that will now write to a log and say, so if I hand it to you, I don't know what your name is, so I'm going to say audience member number 10.
It's Val.
Right. Val? Oh, okay, Val. So if I hand it to Val and I say, all I need to know is that the person I think of as Val is responsible for this, right? It's writing to a log. Every time you use it, it's saying, Val did this, Val did that. Val approved the Japanese knotweed. Val, how could you, right? No, I'm not thinking you would do this, just an example, right? And then I could choose to revoke access. So the interesting thing about a capability system, and here's a fun digression. Let's get into the nature of time, right? Why do people keep doing access control lists over and over again? It is because of the nature of time and narrative, right? Most of the time we were talking about things, we were talking about what people did. We were in a lossy perspective where we were giving in the world of narrative, right? this person can do this, this person what. It doesn't matter that your car doesn't care who has access to the key to drive it. We're used to saying, Val can drive the car. And so if somebody says, how do you implement this car thing? They say, well, I guess I should have, this bouncer who checks to see whether or not Val can drive the car, right? And that's because our language is retrospective, right? Even though action is forward-moving, right? So I'm getting into some real theoretical shit here today, I didn't realize. But I hope you signed up for it, because that's what you're getting. Anyway, why did I even bring this up? I don't remember fully. What I'm trying to tell you here is that it is possible to compose these things. So, and the great thing is, it's possible to compose these things out of just the most basic primitive vectors that exist in the system, and you just build it on top. And that's why we have people continuously returning to identity as the way that they end up handling authorization and authentication, when in reality, references, possessing a reference is it's a sufficiently powerful paradigm when you have a powerful behavior encapsulating system to be able to build everything you want. All right, any other questions? And also, where are we on time? I think we're like right at time, right?
If no one has another one, I have another one.
Was there another question? Yeah? No? Yeah? Brilliant. Hi, great presentation.
Thank you.
My question is about trying to understand this better. If it's a peer-to-peer system for, let's say, games, and you have objects, how if an object is held by one participant, what happens if they go offline, or is that object no longer interactable, or can they transfer objects to other parties?
That's a great question. Right, so I was showing off CapTP, and this stuff is not exclusive to games. Games are just great examples, by the way. Just really light people up as in terms of getting to understand things, right? But games are great examples, and so the garden demo was, was a game, right? What happens if we have a network problem? When what if Dave said, here's a capability, connect here, and start interacting, and there's a network severance, and now I can no longer do things, right? So there are really a couple of choices. And actually, if you've never read Mark Miller's dissertation, let me pull up Mark Miller's dissertation. Robust composition, towards a unified approach to access control and concurrency control. This is like the Bible right here, right? So I had Mark Miller sign this when I had him keynote at my conference. I'm like, Mark Miller, will you sign my copy of your dissertation, right? And the reason is, this really lays out most of the things. And one of the things that lays out in here is, what do you do about connection severance, right? And you have a choice. So when you're doing a game, the correct thing is to break all the references. And that's probably a shock, Christine, you don't want to break all the references, right? Why would you want to do that? You don't want to break all the references. Actually, you want to break all the references. Why? Why is that? It's an opportunity to be notified that there is a severance that has happened in the network. For something like a real-time game, you want the opportunity to reconnect. But capabilities, there are two kinds of capabilities that we're talking about here. There are live ones, and there are ones that are called sturdy refs. Now, sturdy refs can either be these ones that have the random data on them, or to a certain extent, certificates are kind of like sturdy refs. But those are basically references that, even outside of the particular connection, you are able to kind of rehydrate them and get a capability. So when I give that giant URL that says, here's how to connect to this particular object, to you, that's also an opportunity for, if something happens wrong with the network, for you to start it back up again. But in some domains, you don't want this, right? You don't want to be handing out these things that allow you to kind of start over all the time. But Mark points out there's a great reason why you want this, actually. And he gives an example of a spreadsheet. And the user has disconnected from, the user has had a disconnection from the spreadsheet, and the user wants to know that they have had a disconnection from the spreadsheet, right? And they actually want those things to fail and for it to gray out and to say, oh, actually, those things are not going through. And then for it to reconnect and then to be refreshed for, kind of using a hubby model. You get that that's the current state, and it gives the opportunity to reconnect. Now, but the interesting thing is, there's another way to do this, right? So store and forward networks are another way to do this. And actually, one of the really, speaking of Mark Miller, I I'm always shilling Mark Miller in these talks. So let's see here. Mark Miller, here, this one. An amazing talk. How many people have watched it? Not enough, I'm guaranteeing you. All right, how many people have watched it? 4.2K views, actually more than I would expect. Mark gives a wonderful example of how these abstractions, and what we're talking about with OCapN, they don't just work for live connections. The same perspective, now they're blockchain-y people. I'm not a blockchain-y person. I'm like, let's set up a social network where we're allowed to forget things and get things done, and it's more like email, right? And also let's do games, right? But I see the value of this in some particular use cases, right? And also quorums, some use cases, and also store and forward networks are great. Maybe you have limited connectivity. Maybe your particular use case, you want to be able to handle that, right? Carrier pigeons with micro SD card packbacks. Maybe they're actually dropping it off at some store and forward network where you go pick things up. If there's some failure, you go whatever, right? People have voicemail for a reason, right? So it is possible to layer these same abstractions on top of, and so this is when I said we have net layers. It's actually possible to layer these things such that you're able to swap out the particular network abstractions that are applicable to your particular task. Now, one of the things that we have not seen enough of is what happens if you make a video game that was designed to be over a live TCP connection, and then somebody starts sending it over carrier pigeons, right? People might not be happy, right? So it's actually true, I think, that these different net layers will actually have different perspectives and opinions about what kind of guarantees they provide, how much privacy they provide, so on and so forth. But the good news is, and we're working with the Agoric folks on the OCapN stuff, by the way, that it is possible to be able to if you would like something that is long-lived, that to be able to, and they figured out how to hook these things up so that you can even communicate with a blockchain over the same CapDP design, so that you're able to, so that those same perspectives exist, basically. In that case, session severance is rare. The only case in which session severance occurs is actually when the two parties are no longer able to agree on what the state is between them, right? One of the nodes crashes, gets restored from a backup, and maybe it actually, or they have some divergent. I mean, probably everybody here knows about the double spending problem, right? If there's a way in which the two operators are no longer able to agree on the history, even in a store and forward network, even in replication, is always possible for a session severance to occur. So I don't believe it's possible to get around this problem of session severance, but it is possible to have net layers in which session severance is rare.
Hi. So I'm working on a data mesh project, and each of the it's a peer-to-peer network. I was very interested in your proxy object and this kill the references idea. In my case, I'm thinking like each of those proxy objects would have would be released based on governance policies over the network that for data quality. Right, so the references are flagged in the case of if they're IPFS CIDs for I/O, like data I/O, arbitrary. In your example, I got the impression that an actor was assigning those objects, and in my case, a council will be releasing those objects.
Sure.
As a result of what they monitor on the network. What was your example? I'm just confirming.
So it is possible at two different layers of the network to model in a governance process that would resemble what you are asking for, and while still actually using the paradigm which I'm talking about. So let's talk about the first one, right? The first one, see a lot of people talking about blockchains, et cetera, and they talk about consensus and things like that, right? That one is that you have an abstract machine that people are coming to consensus on as in terms of like what it is doing, right? Has a structure as in terms of how it operates, and what you're really agreeing on, especially, is the order of which events are being accepted into the network. and then those are able to do different things to move forward the abstracted machine. It's possible to do that kind of thing. But what's more applicable to your use case, there's no reason you can't take the more fundamental approach of having just these generic objects that just operate based off of holding a reference. And what you can do is you can say, this object will only permit forwarding that message based off of, and then there's these other parties which have references to that proxy, and they're control proxies, right? So an example, let me see if I can pull up the GPX mix, Spritely, let's see here, where is it? Moad, let's see, Moad 2. Is that where it is? No. Well, you know what? Maybe I'm going to do a bad job here. GPX, MISC. Well, I wanted to show you off a cool thing, but maybe I'm not going to get to. These are all like my private art things, so don't laugh at me for my private art things. Oh no, wait, no wonder. So I was not prepared for this, so I'm doing this live. So these are from some of our own internal mockups that we've shown in a couple of presentations, but let's see here. Profile. It's a sidecar. Sidecar associated revocable. Here we go. I'm going to open this one. All right. So in this particular case, this is actually how do you end up having a social network thing where there's a person who's on the network where maybe everybody's able to send, for example, a message to this person's profile, but maybe like it goes through some screening or whatever in the default case. But we would, in this particular case, we've chosen to give this other person a proxy, which this is a proxy right here that they're allowed to use, but it doesn't have any sort of restrictions on it, but it does attribute them, right? And what we have here is basically a fuse. And this one person has the ability to press the button on the fuse. If they press the button on the fuse, you can guess what happens, right? The thing doesn't go through, right? Now, in this case, the person's pointing at themselves as in terms of whether or not the messages can come through, right? But you can have this separate. You can have whether or not it can do something for a particular object, and then a different group of people, and maybe, like they vote. There's like 5 out of 7, right? And if 5 out of 7, it allows the message to go through, right? It is possible to compose those types of patterns, but you compose them out of the more fundamental objects, right? So Goblins is not opinionated as to which particular governance structures should be used. And I say Goblins, I'm not saying Spritely, right? Because the Spritely Institute is working towards community pattern stuff. And what you'll notice is that for an organization that's called Spritely Networked Communities Institute, I did not spend a lot of time talking about communities except for the idea that code can be social, right? And that's intentional. That's because we're in year 1 where we're getting our fundamental stuff. So I showed that virtual world thing where it's like the 3D virtual world where they figured all this stuff out back in 1997. Hilarious video, by the way, if you've never seen it. EC Habitats beta at the Avatars 97 exhibit. It's got Randy Farmer 30 years ago in it. Sure enough, here is a virtual world. It's got a character in it. And they do all the things. The character walks around. It's able to interact with other objects. It dances very weirdly. I don't know why. Why are they making this character dance like this? They chose to do it anyway. But it's able to traverse through the different things. Now, what's interesting about all this is that all this stuff sat on the shelf, and you see people these days, and they're like metaverse, right? And most people who are saying metaverse, I'm like, yeah. And the reason is, I really care about the types of things that people think about as the metaverse, but most of them have it wrong, right? They're obsessed with the goggles and gloves version of the metaverse. They think, oh, the really hard stuff is making it like a 3D experience. You can make all this stuff work in a text adventure. If you can make it work in a text adventure thing, you could hire any studio to be able to do the hard parts on top. The hard part is how do you get collaboration to a degree where it's seamless enough so that you can have something that's as rich as the current world we live in. It is very hard to have collaboration that resembles being as rich as the world. And so in the first version of Spritely, before we had Spritely.institute, there was Spritely project.org. And actually, this one almost had like a monster manual with a bunch of characters on it, and it really confused a lot of people. And so when we created the nonprofit, we decided to call ourselves Spritely Institute, and we're slowly bringing back the characters in and stuff, but in a much more careful way than just people thinking we're making a video game, which is kind of what I gave everybody the impression because it was called Social Worlds Await. This is when I was doing it by myself before everybody else came in, right? Before we started a nonprofit, right? And hired a bunch of other developers. One of the when I started founding the Spritely Institute with Randy Farmer, one of the things Randy Farmer said was, you put the word virtual worlds on there before the metaverse kind of exploded again into the general public, and you're going to really regret that you did that. And I'm like, what? What are you talking about? and then, and sure enough, that is exactly what happened, right? Like, in a large portion of that is because understanding what the hard parts of this completely fell on the wayside. Meta spent so much energy on the wrong layers of the stack as in terms of what was really difficult. The really difficult parts were not the interface parts. The really difficult parts are the low-level technical parts that allow for collaboration in the system, and then on top of that, the community governance parts, right? The problem is right now, the systems that we have are so particular to a paradigm that is not secure and is also not built to be easy to think about building and experimenting with abstractions. So actually the reality is, I don't know if your particular governance model will work or not, and I don't need to know, right?
Right.
What is actually more valuable is being able to create a substrate in which many different forms of governance models can be experimented on very easily, and we can start to find out what is really good for humanity. That's what I really care about. Right? Now, we are going to, as we move upwards in the stack and move towards the more social side of things, be a bit more opinionated in terms of, here's how you'd be able to construct a community that has moderation abilities and stuff like that in the way that you might expect, right? But what is valuable, I think, about a layered approach is it permits experimentation at every layer of the stack, including the social layer, right? And right now, it's too hard to experiment with those kind of layers. So that's my opinion. Long-winded, to your very reasonable question that most people would have answered in 30 seconds, and I probably took about 5 minutes.
No. I appreciate it because I've used the actor model to do the same thing that you're doing.
Oh, great.
I did it, this proxy idea, I used inheritance a long time ago.
Okay,
So
cool.
right now I'm just trying to apply it to, I don't know, my job now, I guess.
That's great.
But
That's great.
very, very good talk. It was like one of the best talks the entire conference.
Glad to hear it.
Thank
Even
you.
though I came in completely helter-skelter, right? Like my laptop falling out of my hand and unable to drink water, right?
That's the story of my life.
Okay, good. Hello, hello.
Hey, so the capability crypto world, especially the OCAP model and the Agoric papers tree of things, and the Merkle tree family of things have been divided throughout kind of like the history of all of these systems, and they haven't interfaced that much. They're deeply interrelated, and it's pretty clear to me that most of these systems aren't quite gonna work well until some merger of these two models happens, because they're operating on the same set of things, and currently systems of one model or another model are kind of incompatible, or not exactly incompatible, but they have different solutions for some of the same problems. Have you thought about that range of things? How do you see those mixing, and to what extent is that part of like the recent OCapN work and other components and so on?
I have a fun blog post that every now and then gets thrown around called Beyond the Shouting Match, What is a Blockchain Really? And it takes about 12 different perspectives on what a blockchain is. That is not why I brought it up here. Actually, the reason I brought it up here is because I don't know how to find this image otherwise in here. Here it is. This is the one I wanted to show. All right. This is Mark Miller's diagram that was from that other presentation that I mentioned, that's the one they gave to the cryptocurrency developers. This is the thing that I think really helped capture my imagination. Now, saying that there are these different layers of abstraction. Now it says JS OCaps. we scheme people, of course, think we can participate, and so do the Agoric folks. The e-rights is the financial stuff that's on top of here. What's interesting is that the financial stuff just turns out to be like the mint, like one particular application of more generalized computational things. And but you have machines all the way down here at the bottom, which are these abstract things that have objects on them that you're communicating with, right? And then you've got VATs, which is a weird term that OCap people like to use for a particular event loop that's talking to another event loop. And then you've got the objects that are on top of it. What's really jumped out at me about this talk is that Mark said, oh, hey, take a look. You've got, all of these things can be perceived as in terms of particular object, just being machines on the network that are, as first classes in one another. The solo machine and the quorum machine and the public chain are just all abstract ideas of the machine. And so this is basically what's happening with what the Agoric folks and them working with IBC and stuff like that have tried to do. It's not my particular layer of focus, but here's a way in which I agree it's pretty interesting. So I showed off this time travel thing earlier, right? You can tell I kind of like games, right? What's interesting about this, and then rolling back to the Mint example, is that if you wanted to make a multiplayer version of this where there's two ships moving around, they're both shooting at the same time and everything like that, you could scale Goblins code or other types of code that are like Goblins up to a blockchain or a quorum trivially. It's not actually really a hard problem. What you do is you have the same deterministic code, and so it's easy to think about this when you think about a multiplayer game, and this is what like fighting games do online and stuff, right? Is that when, and if you ever played like a Super Nintendo emulator, right? Like it rolls, like you have netcode, and they just somehow added multiplayer to every Super Nintendo game, and how do they do it, right? And the answer is, is that basically what happens is it optimistically sends the messages that you're able to do forward, and then it rolls back to the state that you last agreed upon, and then plays forward all the things that happen within the latency so that you just get the illusion of things moving forward, right? One of the reasons why, I don't spend as much time in the Merkle tree and blockchain type spaces, I think most of the people here. But one of the reasons why I like working with the Agoric folks so much is I really love the idea that that people get the impression that, and I know not you, but people in general get the impression that blockchains have these magic properties to them, and that when in reality they're just one way of doing an abstract machine, right? And the same code can work across multiple abstract machines. All the way back, and in fact this is exactly what Agoric's doing with their blockchain, all the way back to the ode to the Granovetter diagram that Mark and company did in the early 2000s. They show off like, oh, okay, here's how to. It's the same Mint example that I showed off earlier, right? Here's the E version of the simple money, right? And this code can work over a blockchain, and that's exactly what Agoric's blockchain is doing, right? And so I know you were making a statement. I'm trying to bring this to the rest of the audience, right? What I think is the interesting thing, and again, maybe this is me being a little bit too much of a language nerdery lady, but what I think the really interesting thing is if we could get to the point where we think less about the particular, whether or not something's being rolled out on a particular node versus on a blockchain, and we write generalized code where this thing could be local or it could be on a quorum that could have a governance model like what you're discussing, and it could be a particular group that maybe really needs to represent the needs of a very small community or something like that with a quorum, and they can agree on what the object is doing. And it can also work on a blockchain if you want a globally permissionless type system. Same code works, right? Same ideas work. And the interface for communicating with them also works. I don't know if it's true that we're not going to see success until those two components start talking to each other, but I know that it feels like a big missed opportunity for me, for the world, to not understand that these types of things can talk to each other, and what and that I quoted this line from Dean Tribble, CEO of Agoric, actually, who said something on a podcast that I thought was really great. I'm going to read it. One of the problems with Ethereum is it is tightly coupled as possible. The whole world is a single sequence of actions that runs on a computer with about the power of a cell phone. Now that's obviously hugely valuable to do commerce in a high integrity fashion, but if you can only share a cell phone's worth of compute power with the entire rest of the world, but you can only share a cell phone's amount. But that's clearly going to hit a brick wall. And we've done lots of large-scale distributed systems, whether payments or cyberspace or coordination, and the fundamental model that covers all of those is islands of sequential programming in a sea of asynchronous communication. That's what the internet's all about, and that's what interchain's about, blah, 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 and that's what, and that's what physics requires you to do if you want a system to scale. So, I don't know whether or not it's required to be able to hit that point, but I do think that it's a big opportunity to realize that abstraction perspective, and I think it can bring a lot of clarity to things. And a lot of opportunity for internet collaboration.
Yeah. So what I'm getting at is.
Oh, okay. Sorry, I interrupted you. Right?
No, this is great, and this background was what we needed to kind of like dive into the question. So it's part of the point. In the JS-CAPS model or the OCAP model, or even in the BAD model, or potentially up in the eRights model, when you start addressing the programming language itself, using hash linking, and you percolate the hash linking in the code itself, and in the parameters and so on, you get this very different distributed computation model that has the benefits of capabilities, plus the benefit of distributed programming that comes out of the Merkle tree accumulation property. Meaning, when you have the hash of something, it means that you have the plain. When you have the cryptographic hash of something, it means that you have the plain text to be able to do it. So it's kind of like a capability in a way. It represents a capability. And you can mix this with kind of Lamport clock style stuff to then generate accumulations of traces of events using hash linking. So you can extend this all the way to things like CRDTs and whatnot. And in a sense, all of Git and all of blockchains and so on are really just kind of an expression of this property extended to different use cases. So kind of what I mean by a merger of these two models is that there's something very fundamental about the hash linking accumulation process, which these days is not just a standard cryptographic hash, because now you have vector commitments and other proof properties that have the same kind of accumulator property, and kind of information in a distributed system moving, plus the properties of the bearer style capability represents the right to perform some computation, and that once you achieve some fusion of these two models, a whole set of problems drop out. And so that's kind of what I mean. It's like these two families of programming systems have explored different parts of an overlapping problem space, and like we're very close to some fusion, but even in the current agoric stack, it's not actually fused, right? Like the programming language isn't looking at the parameters and so on and modeling them as the hash linking of things. If you think of a CRDT, it's like a very far away from what the SES and other components are doing. And so it seems like we're super close to this kind of distributed runtime that can give you these strong superpowers plus replayability, memoization, and so on that you get out of like the hash linking. So that's kind of like where the space where it seems like something doesn't exist that needs to exist.
Yeah.
I'm going to intersect both of your ideas right now. That game that you showed, I don't know what the name of that game is.
Oh, Terminal Phase, the space shooter.
Yeah.
It's fun. You should try it.
Okay, so this is a question. I'm interpreting this abstraction as all of the possible means at which the player successfully completes the game. Okay, it's a projection of all the routes that the player could take to successfully complete the game. Am I interpreting that correctly?
No, it's
No.
an interesting problem. The projection of the routes that a player could use to complete the game definitely gets into a different area of interest of mine, which is solver type systems. And we've built some of those on top of the tech that we have here. But I am not going to propagator pill this audience. What you're really seeing here is the moments in time that happens when you move backwards are representations of what have occurred within a particular state, that happened with that particular moment in time. When the player moves backwards in time, and then they move forwards in time, they're not exploring all possibilities. They're exploring the possibility, the particular choices that were made in that time, right? And then because they're starting from that point that they were at, and they're moving backwards, and then and there's some halting level type problems that are like if you want to explore for all generalized code, like all possible possibilities, which are also get into the domain of really fun things like propagators that I really love to talk about, but definitely cannot talk about in this talk, which I'm dramatically over on time in this Q&A, but nobody seems to be stopping me.
No, don't stop.
But what is interesting is that you can see the player move backwards, and they can choose to stay at that point and start changing their decisions, right? So it's up to the player to decide which different decisions they could choose to move down and explore as they move backwards in time and then see what their alternate histories would be. But the system is not itself making those explorations until the player is particularly doing it in this example. If that is the time travel science fiction that we will probably be able to fit into this the science fiction, science reality, Goblins, in this particular session.
It's like a user's analysis of their own behavior.
Yeah, it's a system capturing what the particular behavior of the system was at that particular moment in time.
At that particular moment in time.
Yep.
I'm trying to think about the value of that within the context of a peer-to-peer network. I'm thinking it's like a route.
I mean, the value
routing?
to it is things like quorums and blockchains and stuff like that, which do this type of thing under the hood, right? They do move back and then play things forward as the system comes to consensus and stuff like that. And the value is also when it comes to a developer trying to debug a problem and understand what happened at a particular moment in time, right? So those are the two examples in which, like there's a silly example of time travel for the video game, right? This is just to get it lighting up in your mind, right? But the two practical examples that we've talked about here are building some sort of quorum-like system, whether or not it has public consensus or not, and also having trying to understand what happened in a system when things went wrong, right? Which is not too far from a player who's like, oh, I screwed up there. What else could I have done, right? Any other questions? Or, I mean, we're probably dramatically over time, but if I will continue to sit here as long as you permit me to, or stand here, in fact.
Alas, time is sliding into the past, and we must move forwards. Thank you very much.
But we have this great time travel feature.
Not in real life, unfortunately. Thank you very much.
All right. Thank you, everybody.